So we talk about what is a vector field. A vector field is a function. You can think this as a vector valued function, right? And if we say it is conservative, if this vector field is the gradient of some function, I don't have to know what the f is, but as long as we know there exists some function f so that the gradient of this function is the same as the vector field that you have, then we say the vector field is called conservative vector field. And the function also has a name called a potential function of the vector field f. Okay, so naturally we'd like to ask whether this is true. So naturally we have this question: if we're given a vector f, is f conservative? If it is conservative, we got some nice properties, and this is just the saying. Is there a function f so that the given vector field is equal to the gradient of the function? Okay, same question, so different way of saying it. So luckily we have tests for to determine whether a vector field is conservative, and depends on whether this is a vector field in R2 or in R3. We have similar but different ways to check whether the vector field is conservative. Okay, so I'm gonna erase this board and write down the test for you. If you need to write down what we have on the board, you can pause the video. The vector field in R2 is conservative if and only if the partial derivative dn dy is equal to the partial derivative dn dx. Okay, so we know that it's probably not as easy to find the potential function to see if f is conservative, right? If f is not conservative, you don't even there is not even a function that you can look for, right? So this condition then would be the condition that we check to see if f is conservative. So let me give an example. So if I'd like to determine if this vector field 2xy and x squared is conservative, then this is my function n, using according to the formula. This is my function n. Okay, so then I would like to compute the n dy and see what that is. So this is 2x, and I'd like to compute dn dx. So differentiate x squared, I also get 2x, and now you see they are the same. Therefore, according to the test, f is conservative. Now we can tell whether f is conservative without knowing whether there exists a potential function, or we don't know any information about the potential function. Okay, so this is a simple test to see whether a given vector field is conservative, but this is only for vector fields in R2. What about a vector field in R3? That will require something slightly more complicated. So I'm gonna talk about it in another video.